So for this second portion, what we're going to do is we are going to recreate that Diablo style item text identification effect that we saw. And just as a note, we're not going to be creating it to the same level as you might see in like Diablo 3. There's a lot going on there. For example, their text organizes itself such that none of the text is overlapping on screen. Additionally, their text is all clickable, so you can pick up the item. We're going to kind of begin approaching how that kind of system can be set up, but we're not going to go to the extent at which Diablo is set up, because there's a lot then in the background that you need to set up where you're paying attention to how many characters you have, where they're positioned on screen, if anything's overlapping them, that kind of thing. So there's a lot of logic there to get that kind of polish done on that kind of a text system. So the first thing we're going to do is we are going to create some initial blueprint stuff that we need just so that we can have some items in the world that we can kind of begin talking about. The first one's going to be a spawner that I'm just going to put up in the air here, and I need to give it some items to spawn. So I'm going to create two blueprints. One is the spawner, one is an item blueprint. And this item is going to contain basically just a cube that we are going to make a little bit smaller, and we're going to make sure we simulate physics so that when this thing is simulated, this cube will fall to the ground. Inside the spawner then, on the event graph, we are going to override our tick rate, and we're going to make it so every 3 seconds this thing does a spawn actor, and we're going to have it spawn our item. We're going to split this out, and we're going to give it the location of wherever we currently are in the world. So we'll get a reference to ourselves, get our actor location, and we'll use that for our spawn location. That's basically all I'm going to do here right now. I am going to add a little bit of random value here. So what I'm going to do is I'm going to create, actually what I will do here is, instead of just spawning from ourselves, let's go over to the viewport and let's add a bound. Let's add a box collision. So there we go. And we're going to actually make this have no collisions. We're going to use this as a bounding box. So what we're going to do here is we are going to say, I'm going to drag this out, get scaled bound box extents. And we're going to say get random point in bounding box. And so this gives us our extent, and our origin is going to be wherever its origin is. So get world location. And now if we take a look here, we can see that it is going to begin spawning just an item in some kind of random position so that we don't have quite as much overlap with it. Now we're going to have to pass some information off to the widget that we're going to create here. So we're going to make ourselves a struct, and this struct is going to be an item data struct, and it's going to have 3 things. The first thing we need is a reference to whatever actor we are currently looking at. Whoops, ref. We're going to need some text, so whatever this item is supposed to be. So this is going to be item text, and we're going to need a color for this text. So this is going to be text color, and we're going to make that one a linear color. Save this, and then that is done. What we'll do then inside of our item class is we will add this variable in. This will be item data. It will be of the item data struct. And in our construction script, we're going to do a couple things. So what we're going to do here is we're going to give ourselves a sequence, because I like using sequences to organize kind of just flow. And we're going to do 2 switch on ints. And we're going to go with 4 pins here. I'm going to copy that because we're going to use it twice. And this is just to give us some random information, random integer in range, random information here so that we can have some variance in what we're seeing on the ground. Ideally, if you're making this for a game, you're going to have these items, whatever this item is, it's going to have a more complex system for generating it. You know, like potentially it's going to have percent chances for rarity or type, or you may have some other kind of system that basically will populate, you know, a data structure, as it were. But for our purposes, we're just using this to generate some random information that we can populate stuff with. And so what I'm going to do here is I'm going to give myself 2 local variables. The first one being the text, the second one being the color. We'll make sure the color is a linear color, and we will make sure the text is actually text. Then I will set this. I'll copy this 4 times. And so what will happen here is our switch will, based on this random value, will pick one of these 4 options. If you had, for example, a spreadsheet or something like that, you could also use that to potentially populate the stuff, but that is a different topic. So we're going to stick with this for our how we're going to randomize stuff. We're going to do the same thing for the color. And in traditional kind of fashion, what I will do here is I will start with like a green for, you know, maybe it's uncommons, and I will go to like a blue, and then we'll go to like a yellow, and then we'll have our fancy kind of orangish color at the end there. And so after we've kind of set all of these, what we'll do is we will take our item data, we'll kind of split that structure pin, and then we're going to populate that struct with information. So we'll get a reference to ourself, store that there. We will just drag our text and our color there for other information. And so that's populated at the time of construction. And so now, as it is currently spawning these guys, it will be spawning some extra stuff there. They'll all have the information that we need to access later. So let's go ahead and create our widget. To make this easier on us to implement, just to send the data and such, what I'm going to do is I'm going to create this widget. This is going to be our OnPaint override. And I'm going to implement this widget on the spawner. This is what's going to actually call this. We're going to create our widget here. And remember, you don't actually need to have widgets created on a player. It's usually a better practice, but for purposes of what I'm showing you, I can just leave it here because I'm going to be adding it to the viewport regardless. And what we're going to do here is we have to send the data to it somehow. So what I'm going to do here is, because it's easier for me, I prefer this method, and in case anybody hasn't seen this before, we're going to be using an interface. So this is going to be my my OnPaint interface, and this is going to just be called, this first function here, this is going to be called send item data. We are going to send it an item data struct. This is new item. We're going to go ahead and compile that, and that's all we're done. That's all we're doing here. If you have not seen an interface before, it's a different way of communicating that does not require casting and reaching into, from having a blueprint reach into another blueprint. There are some very, very good videos on blueprint communication. I highly recommend them, especially if you grab the video by Zach Parrish from Unreal. He talks about casting, these blueprint interfaces, and he also talks about the event dispatcher, which is another very good method if you need to have a one-to-many communication method. So we'll jump into our widget now. And the entire reason I made that was just because when we jump into our OnPaint function here, I don't want to have to use a get all actors of class, which we'll use that real quick just so that I can show you how this would be going. But we don't want to use this. So what I will do here is I'll plug this in initially, and I will say I want to get all class of item, and then we're going to do a for each loop, and then we're going to run that. And this is where you might encounter an issue if you're using for each loops inside of here. Make sure that you don't connect this here. If I connect and I do something here, like for example, here's our out list. So let's go ahead and cast to cube, or let's get item data, because this already is technically a casty node. And then we can split this, and what we'll do here is we will simply do a draw text. We know it's going to overlap, but I will do a draw text here, and for each of these we will just draw our text. Make sure I connect the context line. And if I do this, it's not going to matter how many objects I actually have here on screen. You'll notice that, oops, I need to actually select a font. You'll notice that in the upper left hand corner always just says one thing, and this is because if you're used to C++ and have any familiarity with OpenGL, this return node is kind of the draw, this is effectively a the indicator that you're done in this loop. You're done inside of OnPaint. So by connecting it here, what we're doing is the very first time we run this, we leave it. This will stop running basically after the very first one. So we want to make sure that we are running it off of the complete node. After we've drawn everything, then we're ready to push it to the screen now that we know what we want to draw, and then it will actually begin overlapping the text that we have there. As you can see now, it's starting to overlap. So make sure that your return node is off of the complete and not inside, not attached to anything inside the loop, or it's going to get very, very cranky at you, and you're not gonna get what you were expecting to see. But what I can do here now is I can actually go ahead and I can use this actor reference, and I can go in here and I can say get cube, or I can actually cast. In this case, I need to cast to my item. I'm going to make it a pure cast because I know exactly what this is. I know exactly what I'm working with. And I'm going to go ahead and say get cube component. Actually, get cube location. There you go. Get world location of cube. And what I can do here is then I can use this and I can say project world to screen. And what this is going to do is it's going to ask for some kind of a screen, like whose screen. So I'm going to say get player controller, and I'm going to go ahead and plug that in there. And I'm going to say this. So this is going to give me now the screen position on my player controller 0 of this object. And so what I can do here is I can plug that in, hit compile, and you're going to see that Shield now is somewhere different compared to the other one. You'll also notice that it's not exactly where it's supposed to be. You notice that they're all kind of into the upper left and such. Much of that is because the screen is not being adjusted as far as scaling is concerned. This is a very, very important point to mention. Because we are dealing with scale issues, we're going to need to actually adjust this based on our screen scale. Luckily though, this is a very, very simple thing to do. All I'm going to do is I'm going to get my viewport. I'm going to go get its scale, and I'm going to take whatever this position is, and I'm going to divide it by a float, and I'm going to divide it by my scaling. And by doing this, I will correct this now for any scaling, any screen scaling issues I have. And so now, by using that, the text will now properly follow all of these items. So I go ahead and hit play here again. I could scale this around, and you will see that as we get more and more items, that they're all going to remain properly on wherever they're supposed to be. Although you'll notice that if they're off screen, say if I actually do this, if they're off screen, they can do something very weird, which is show up in the upper left hand corner. So we need to add some logic in to account for that. So what we need to do is, before we even begin drawing it, we need to take this object and we need to check to see if it's been rendered. And in order to check and see if it was recently rendered, what we're going to do is we're going to drag out from this its reference of itself, and we're going to check. We're going to ask it, was recently rendered. Another very useful node, and we're going to actually have a branch here because of that. And so now, if it wasn't recently rendered, and there's a tolerance here, you can kind of adjust this. I'm going to actually decrease this down to 0, 0, to just 0. What that means is, if this was not rendered this frame, then I don't want it to draw it. So if it was, go ahead and draw the text. If it wasn't, don't do anything. There we go. There's our bow. It goes off screen. We don't see it anymore. We don't see anything. And now it's back on screen and we see it. So now we only see the items when they're actually on screen and such. There's another little check we can add in here to kind of help with this before we even do the get all actors thing. The very first thing I'm going to do is I'm going to add a branch in here, and I'm going to ask it, I'm going to give it a player controller, and I'm going to go ask it to just pay attention if there is a keyboard key that is down. And this is the if is input key down. And I'm going to use Alt. This is kind of hard coding. What I'm doing is I'm hard coding my left Alt key now to basically toggle on or off if I want to even draw all of this. If it's not, though, I do need to make sure that I add in this this false line to go to the return node. Because if I don't, then I risk this getting stuck in OnPaint. And I don't want it to. I just want it to kind of go here and bypass this OnPaint portion if it's not being used. And so now I can kind of exist here. The items are falling to the floor. If I hold down Alt, I will see the items show up. If I let go, they go away. And so this is a very basic thing. So the last thing I want to do then to kind of complete this is I want to add in that box. So what I will do is I will say draw box. This will kind of give us that background, the extra background stuff that we have here. And so I'm going to go ahead and double click here to give myself another context line. And what I will do is I will give this the same position to start from. The only difference is I need to make sure that I first give this just an asset, a slate brush to use. So we're going to go ahead and we're going to create that slate brush again. And like I said, this is going to be, I'm going to call this thing empty, specifically empty slate. And it's not going to have anything. I need a slate brush because I do not believe that this actually box works without it. And what I'm going to do here is I'm going to give this just the black color, and I'm going to make it about 0.5 or so for its visibility, and we're going to make the size determination based on the text. So what I need to do is take this text then, convert it to a string so that I can begin doing some string stuff on it, like length. And then depending on its length, I'm going to split this. I want to actually make this a different size so that this looks a little bit cleaner. And so this is where I'm going to play around a little bit because I don't know the exact value. We're going to start with, I think the value is 17 for this particular font size and this particular font. So if I'm going to do my Y size as, let's make that 20 to begin with. Let's look at that if that's too big. I don't see anything there because I did not select the brush. So there's our empty slate. And there we go. So it's a little bit long for our text. But you'll notice no matter how far away I am, like I said beforehand, that text stays the same exact size, meaning that it's distance independent, which is very, very nice. But let's shorten that up. So it's not quite 17 per. Let's try 14 per letter. That's closer. It's probably closer to like 13 per letter or something like that. But what this means is that the more letters there are in this string, the longer we want in the X direction our background box to look. There we go. That looks about right. Let's get another word other than a bow to show up real quick. Everybody's going with a bow, apparently. There's a shield. Yeah, that's pretty good. And now the last thing we need to do is take this color, and we're going to plug that into our text tint. Now, I'll go ahead and compile. I'll hit play. And we're going to actually, real quick, just change this spawner speed up to like every second, just so this is a bit faster. Go ahead and hit play. Now we're getting more items. Yeah, now we're getting some rares and some other different colors, and so this is kind of, you know, now if I need to see what is on this, you know, this is better than this might be a better option for games or for your game than if you have to like specifically mouse over something and have it like have a little like pop-up window or have other information. This is something where the player can begin just looking around and getting a quick idea what is in front of me, what is on the ground, what is interactable, or if there are, you know, waypoints far away that you need them to always be visible at a certain size, then that is useful. You can also specifically make it so that these are always visible on screen. Like right now, if it's not rendered, we're ignoring it. See how it's like if I go behind items and such. Maybe you want, maybe you still want that to occur. So you can you could take that logic away and still have it show up. The last thing then we'll look at is, because I had mentioned beforehand, I don't like using this get all actors of class thing in here. This is very, very inefficient, especially since, as I said, what we're working with is effectively an event tick. This is an every frame action. So we need to kind of rewrite that so it's not collecting everything all the time. And it's going to require two things. The first is we're going to have to change this loop. This loop, we can't use this. We're going to need to use a variable that we store inside of our widget. And so I'm going to add another variable here, and this is going to be current items. Let's see, on ground. We're going to make this an item data struct. We're going to make this an array. And the first thing I'm going to do at construction is I'm going to make sure that I clear this, just to be sure that I have a completely empty array to work with. And we're going to now apply the, did I make it yet? We're going to apply the interface that I had. So widgets, if you were not aware, can use interfaces just like any other class. You go to your class settings and you will see an interface here. So I will go ahead and I will add my OnPaint interface. And you will see that I now have my interface here, send item data. So I right click and I will say send item data, and I want the event. I want this red box thing here. And I know that when this is being called, what's going to happen is it's going to send me a new item. So what I will do is I will get this item and I will go ahead and I will add that to my list. And so now, whenever this is called, it's going to add a list of items that I should call. And what we do then is over at our spawner, when this thing is spawned, what we will do is we will actually call from our widget that we have here. We will go send it a message. We will send data item. We will send it the message. And what we need to do is we need to send the item to it. And that item information is stored here. So we're going to get our item data. There it is. Because this is a reference to the spawned actor we just made. So I will go ahead and I will just pass that along. And so now when it's created, it will pass that along to our widget, and our widget will now have a list of the item data that it can store, and it can reference whenever it needs to. But let's say, for example, that somebody picks up an item, it's not there anymore, it eventually goes away. We can even, actually make this occur on here. We can give them a lifetime. So here's our, I clicked on item, and here's our lifespan. So we're going to give it a lifespan of about 5 seconds. And I will go ahead and hit play here. So as our items are dropping, they're eventually going away. So our items only exist for a certain amount of time, but we keep sending it more data, so it has the old data there. So the last thing we need to do on this paint in the OnPaint thing is we need to check to see if it's still valid. So we will go ahead and we will get our current. We will do our for each loop off of this. And then the first thing we need to do is, before we actually use it, we're going to split the structure pin, and we're going to check, we're going to grab this, and we're going to say is valid. And if it is valid, fantastic, let's keep doing what we were doing. If it wasn't valid, we should do nothing. And so now we have a couple checks here. First, is our input key down? Is the item, does it still exist in the world? And was it recently rendered? If all these things are true, then we can draw. We do need to quickly correct some stuff here, so I need to drag this, because this is kind of a not needed thing anymore. So we're just going to reconnect where some of these guys are being connected to. Just kind of replacing all of those. We have one more color value there, and now this isn't being used, so I can delete it. And so now, here's the catch though. So instead of just letting this array kind of keep growing to some huge monstrous amount, if we actually find a array index that actually is bad, we should remove it. That's the proper thing to do. So we should actually remove an index. So remove an item at the given index from the array. So we'll plug that in. We'll plug that in. And then that will remove it from our list in the future. The last thing we need to do is make sure that we actually tell this at the end that now that we've completed this loop, we should go to our return node. OnPaint is finished. So now if I hit play, we have our items dropping. They have a little border in the background, and as they disappear, they are getting removed from the list, so we're no longer drawing them anywhere. And so that is your quick and dirty tutorial for how to set up and use OnPaint. There's a lot you can do with this. It's one of those situations where OnPaint is very much a window into an OpenGL style concept where you can draw lines and you can draw their stuff directly to the 2D palette effectively at runtime and dynamically. So it's kind of one of those, if you're running through games and you're playing and you see something really cool and it's 2D, this is potentially where you might look at implementing that kind of a dynamics thing. Hope this has been useful. Everybody out there, thank you so much for watching.